All right, what's happening, my mathletes? That's right, Mr. Muscarella coming at you. And in this video, we're going to take a look at solving a right triangle. What exactly does that mean? Thanks for asking, bro. I got you. I'm going to tell you. When you go to solve a right triangle, you're going to find all the bits, all three angles, and all three sides. Now, to do this, we'll be using trigonometry. So when you go to solve a right triangle, that means you're going to use the given information to find all the side lengths and all the angle measures. So that is what solving a right triangle means. How do we do that? With trigonometry and Pythagorean theorem. Let's take a look at this first example here that we'll go through together. So check this, right? We've got an example where it says solve the right triangle given one acute angle measure and one side length round measures to the nearest tenth. So notice what we have. So we're given these two things. So we're given an angle and a side. So those are the two pieces of information. So that means we need to find two other angles, and one side. So that means we need two other sides. So we need two sides to find and two angles. Now, because it's a right triangle, that's going to make this really easy to find the other missing angle. So the first thing that we're going to do, that's that first step. We're going to use the triangle sum theorem to find that missing angle. So the triangle sum theorem, you should know by this point in your geometry life that all three angles in a triangle add up to 180 degrees. So the angle that I have is angle J. Now remember, that little box in the corner by angle L, yeah, that means 90 degrees. So we know those two angles, so we'll use that triangle sum theorem to find the value of angle K. So the measure of angle K, that is going to be 180 minus the 90 degrees minus the 30 degrees that we're given. So that tells us measure of angle K. Yeah, bro, we got you. That's 60 degrees right there. So the measure of angle K is 60 degrees. Booyah, we done with that. That was the easiest part. So we just found that. Thank you very much. We got you. Now, the other two sides, man, now we got some options here on how to find the sides, man. And when I look at, I'm going to use the given information, right? So we're going to use the 30 degrees. And I'm going to draw a little line over here to the 30, across from the 30 to where the number 4 is. So 4 is opposite. So I'm going to write down an O next to this for opposite. 4 is opposite of 30 degrees. So I need to find the other two sides using that side that has a length of 4, that KL part. Now, if I go to find the JL piece, so first we're going to find JL, and I'm just going to call that X, right, and make it a little bit easier. Now, that piece right now is going to be adjacent. So that is adjacent to angle J. So in my brain, I think to myself, all right, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. So what I want to do is say, all right, I've got opposite. I'm trying to find adjacent. What trig function deals with both of those, opposite and adjacent? And you'll see, yeah, that's right, baby. We're talking tangent. So what I'm going to do then is use trigonometry to help me find the length of side JL or the variable X. So when we go to do that, so we're going to use trig to find JL or X. So when we do that, now opposite over adjacent. So we already said, all right, that's tangent. So we're going to have the tangent of 30 degrees is going to be equal to 4 over X, opposite over adjacent. Now, again, this is one where I like to call it the switch, right? Because anytime, so now we got an algebra problem to solve. Anytime the variable is in the denominator on one side, and you don't have anything on the left side. The left side just has tangent of 30. Now, secretly, even though we don't write it, there's a divided by 1 there. But we're not going to write that. Because when you multiply 4 times 1, we know that's just going to be 4, right? And when we multiply x times tangent of 30, we know that would be x tangent of 30. But I'm going to show you a hack here, and that's just going to be called the switch. So the tangent of 30 and the x, bro, you just switch that up. So the x right there is going to go where the tan 30 was, and the 4 is going to go on top, and then tangent of 30 goes on the bottom. Now, in our directions, it said, okay, round everything to the nearest tenth. So to find the value of x, that's going to be, and this is where we've got to go calculator. So calculator time. So I'm going to go here to my graphing calculator. Now, a couple things about the graphing calculator. Notice how it says rad right here. You don't want radian mode. You want degree mode. Now, if you're using a TI-84 graphing calculator, then you want to hit the mode button. Make sure you go down and select degree. Make sure that's highlighted. If you're using the other Desmos graphing calculator, then you're going to want to go all the way over to where the wrench is, all the way over here on the right. Click on that. Make sure that bugger down here, degrees, better make sure that's highlighted, colored in, because that will give you the correct answer. If it's on rad, nope, you'll get an answer. It'll just be the wrong one. We don't want you to be wrong. Can't handle that, bro. So let's go ahead and find the value of x, shall we? So we're going to type in 4 divided by tan 30. Now, when we do that, we'll do 4, then divided by, and then the tangent button. Right here in the main menu, you see tan right here. Also, in the FUNC menu, the function, you'll see tan in that spot too. So either way, boom, type it in there. So we type in tan 30, and we get 6.928, blah, blah, blah. Now, we wanted to figure out this to the nearest tenths place, so that would be 6.9. All right, so x has a value of about 6.9, so JL is about 6.9. So the length of JL is 6.9. So now we've got all three angles in two sides. Now, we've got one other side to solve, and that is for the JK side. So to find JK, just kidding, to find that one, we can either use trig or, and I'm going to abbreviate Pythagorean Theorem, PT. So we could use Pythagorean Theorem because, like, bro, we just figured out this guy right here, this x is about 6.9. So we can use that to help us find the JK side. So JK, that value, is when the side that is across from this, where you got to notice some things here, right? Angle L is right there. So JK, that's always going to be my hypotenuse, because we got the angle L, that's a right angle. So that would be the side in the Pythagorean Theorem. We usually call that C in the Pythagorean Theorem. So however you want to think about that, you could call it C, you could call it JK, you could use another variable. But what I'm going to do is I'm going to take the two sides that I have, 4, and I'm going to square that. And then the other side is 6.9, square that, that's going to be equal to, either C squared, or you can put JK squared. Whatever variable you want to use, you're good there. Just don't use X because we already used X. When you do the arithmetic on here, you'll get 16 plus, and then 6.9, when you square that, you'll get a 47.61. And then when you add those two together, you'll get 63.61 for C squared. Now, error alert right here, bro. Take your time, and I know I see this all the time. People are like, oh, I know I need to square root both sides. So they'll just do that. And if you only do that, bro, you're going to lose 1 point, because that is what is called a linkage error. Linkage error, -1 for you, because you didn't square root both sides. You only took the square root of one side. So make sure you write the square root around the variable as well. In courses beyond this, you'll need to put a plus or minus around the C squared, but for right now, only use the positive root. So when you do that, that value of C that we get, so C is going to be about, when you square root that, you'll get 7.9 and a whole bunch of other stuff, right? So 63.61 square rooted, so let's clear that out. So square root, and then got to go back to there, 63.61 is 7.97. So don't just say that that's 8, because is that rounded to the nearest tenths? No, bro, it's not. So make sure you put 8.0. So JK, so that last length of JK is about 8.0. That would be the length of segment JK. All right, so that's it. That's all you got to do is use Pythagorean Theorem, use some trigonometry, and use a Triangle Sum Theorem, and use straight on this one. All right, so that's it for this one. Thank you guys so much for watching. As always, I appreciate you, and make sure that you make it a great day. I'll catch up with you soon. Peace out.